Hello guys, hope you're doing well. My name is Mahmoud Kiasari and welcome to the new chapter of electrical circuit. So at this point we are going to talk about another two interesting some kind of toolkit that we are going to use in order to simplify any other kind of circuit we have. If you guys remember from the previous chapter, we were talking about the superposition, and I told you that superposition has another toolkit with the name of Thevenin and Norton. It means that at this point we do have a very complicated or maybe some kind of normal-wise complicated circuit, and we would like to make it as simple as possible. We would like to put everything inside a black box, and the only thing that we need either is just a voltage source and a resistance, or the current source and a resistance side by side. So without further ado, let's talk about it. As I just mentioned, at this point, we do have a condition that we would like to talk about, the Thevenin and Norton, the ultimate way of the simplification. As you can see, we do have a very complicated circuit. It could be anything. Obviously, it's not just like this, but it could be anything. And I would like to put all of these parts, everything that I have over here inside a black box, and only see two things out of it. It means that the whole thing is inside something. I don't know anything about them, and I would like to connect them to my load, to everything that I like. So at this point, we say that we can mimic or resemble the whole complicated circuit using either this circuit, the R Thevenin and V Thevenin, or we can resemble it using these two, R Norton and I Norton. So at this point, if I look at these two guys from A to B, actually I'm looking at this whole circuit, and if I do the same over here, I'm just looking at the whole circuit itself. Simple as that. So here's the idea. The idea is that any two-terminal network, no matter how complex, can be replaced by a simple equivalent circuit. From the outside, its behavior is identical. It means that I do have the complex linear network. Right now we are talking about the current source, voltage source, and DC, by the way, and we are talking about the resistors. So at this point, if I just look through my box from A to B, I can either see this equivalent, which we call it as a voltage source, and a resistance, which is named as Thevenin equivalent, and also I see the whole circuit like this as Norton equivalent. So this some kind of toolkit is helping us in order to simplify our analysis, streamlining the load calculations, and assistance to design and troubleshooting, obviously. So this is the ultimate tool for abstraction in circuit analysis alongside with the superposition itself. So the first relation, the Thevenin theorem, what does it say? The Thevenin theorem says that any two-terminal linear network containing resistance and sources can be replaced by an equivalent circuit consisting of a single voltage source that we call as V Thevenin in series with a single resistance. We call it as R Thevenin. So we do have a little bit of historical memorial related to who actually discovered that or invented that, and this is not that kind of important thing right now, it's just FYI. So V Thevenin, again, the voltage is the open circuit voltage at the terminal. At this point means that if I assume that my A and B are not connected to anything, and it means that the current goes through this part is 0, I do have a voltage. At this voltage is going to call my V Thevenin. And R Thevenin is the Thevenin resistance, is the equivalent resistance looking back into the network. It means that if I look back to the circuit from point A and B, and if I assume that all of the voltage source and current sources are going to be 0, open circuit, I can say that the equivalent resistance that I'm seeing is the R Thevenin itself. So let's have some steps about the Thevenin. Obviously, we need to do some steps in order to find those things. So V Thevenin is the open circuit voltage. That's why we call it as OC. It means that on that time, my circuit from A to B is not connected to any place and is going to be measured, or we can calculate it at the output terminal. So here's the procedure. The procedure has a couple of different parts. The very first part is that identify and remove the load from the circuit. Imagine that I do have a load that is connected over here. It could be named as RL, it could be anything. And right now I'm going to disconnect everything from A to B. So at this point, I know that the voltage that I'm reading, the voltage of open circuit. Then we can calculate the voltage across these terminals. Imagine that my A to B is over here, and A to B is directly connected to RL. Whatever voltage that RL sees, because of the power rule, is the actual voltage that I need. So if I, by the way of calculation, I can find the RL, on that point I can find the voltage, and if I find the voltage, I do have open circuit voltage. So this V Thevenin, and this voltage, as I just told you, is a V Thevenin. Any valid circuit analysis technique, we can use node voltage, superposition, etc., can be use. By the way, the node voltage analysis and some kind of mesh analysis are another two kind of important analysis we are going to talk about in the future. But right now, let's just talk about the Thevenin and Norton, and then we will talk about these couple of important things, because actually they're going to be useful as well. I do have a condition that my some kind of so-called complicated circuit is this: 12 volt, 6 ohm, and 3 ohm. So at this point, I'm going to look at the whole circuit and say that, okay, I would like to find the VThevenin, the open circuit voltage. So I have to make this one open circuit. It means that no current goes this way. And if I can find the current that goes through that way by multiply by 3, I can find the voltage. So what is the current? It's 12 divided by 6 plus 3 is going to be 12 divided by 6 by 3 divided by 6 plus 3 is 12 times divided by 9 and multiplied by 3. I can find the voltage, or I can simply use the voltage divider rule. We know the VR2 is equals to what? The total voltage times that resistance that I would like divided by addition of resistance. So it would be 4 volt itself, as simple as that. So what would happen if I would like to find the total resistance? So at this point, the RThevenin is the equivalent resistance that we are looking back into the terminals, with all independent sources deactivated. By the way, if you do have dependent sources, they should still be activated, okay? But at this point, we are only going to focus on the independent source. Having the dependent source would make it a little bit complicated, but the concept over here is that I'm trying to help you guys understand the whole thing, because after understanding, that would be just a piece of cake. So here's the procedure. The procedure is like this. We have to deactivate all independent source in a network. I mean, the voltage source, as with V, should be 0. So it means that we should replace it with a short circuit. And then the current source, we have to replace it with an open circuit. You have to just blend. You can calculate the total equivalent resistance between the open terminals. You do that A and B, and you can calculate the total resistance at this point. So with the source shorted, imagine we do have some kind of this condition, and I would like to find the RThevenin. I do have the current source. I don't know what is that, and the idea is this: I have to get rid of that. If I get rid of the current source, or if I make it open circuit, if I break that one, I see what I think 3 and 6 are in parallel with each other. So I do have these two guys in parallel with each other, and my RThevenin is with me 2. So at this point, I know that my RThevenin I can calculate it like this. So let's do some kind of examples together. Let's see it in action. At this point, I'm going to talk about the Thevenin voltage and RThevenin. So the idea is this: I would like to find some kind of amount of RThevenin and VThevenin that I see from point A to B, and RL is just a load, okay? So the very first thing that would like to find is the VThevenin. As I just told you, VThevenin means the V open circuit. So get rid of the RL. I don't care what is that right now. Get rid of that, and it means that my circuit is going to be what? Is going to be open circuit. On the time that my circuit is open circuit means that no goes through this guy, right? So when no current goes through this guy is also going to be canceled. This guy is just acting as a wire. It means that if I can find the voltage that go through 4K and find my VThevenin or V open circuit. So at this point, VThevenin is equals to V open circuit equals to what? 48 multiplied by 4 divided by 16. So that guy is 12 volts, right? Based on the formula that we know related to the voltage divider. And this one is my Thevenin voltage. Simple. Then I have to find the RThevenin. RThevenin means that I have to get rid of what? I have to get rid of my voltage source. So I have to make it this guy as a short circuit, and whatever resistance that I see from the A to B is going to be what? Is going to, at this point, I can redraw the circuit. It will be helpful. 12K, I do have 4K, and then what do I have? I still do have my 8K, because the resistance, the total resistance doesn't care about the rate. So at this point, I do have this one, and I would like to see how much resistance I do have as RThevenin. So 4K in parallel with 12K would be what? 12 multiplied by 4 divided by 16. With this one would be 3K based on the two resistance, R1 times R2 divided by R1 plus R2. Then I do have the equivalent of 3K from this point to this point. So 3K would be what? Would be 11K ohm. You guys would be in series. So finally, I do have my RThevenin and I do have my VThevenin. So I can redraw the whole circuit from A to B. I do have my RL, whatever is that. Then I can have my RThevenin, 11K, and I can have my VThevenin. Which, how much was that? It was 12 volts. The way we are going to use. So let's look at this question. It is related to finding the Thevenin voltage and the RThevenin. So at this point, instead of just being A and B on the left, it's going to be in the middle, right? It means that this guy is going to be my RL. I have to get rid of it as soon as possible. So imagine that I'm going to somehow redraw the circuit. Oh, forget about that. We don't have to redraw it. So the voltage that I need would be from here to here, while I know nothing is over here, because we would like to find the open circuit voltage. If I consider this one as ground, I can do what? I can find the V by using the voltage drop. As we know that we do have two currents. One current is producing by this guy, and another current is producing by another guy. And this one, they do have the opposite amount of current, we know the total current would be what? From this point to this point. But at the same time, 20 and 10 are fighting against each other. So I can say my total current right now, I total, is delta V divided by R total. Is that so? Since I all have 20 and 10 in series, my delta V should be 20 subtracted by 10, because 20 is bigger than 10 and it can win this fight, divided by R total is 30. So it would be 10 divided by 30, and it would be 1 over 3. So 1 over 3 amp is going to be the amount of voltage that actually, the amount of amperage that I have as the green line. So if I would like to find this voltage, like to find the VA, obviously we know that the V open circuit is going to VAB, is going to VA subtracted by VB. Since VB is just ground, it's going to be 0, so it's going to be VA. Finding the VA is going to say that I have to move throughout the current itself. It means that I do have 20. If I can find a voltage drop out of this guy, I can find the VA. So what do I have? I do have VA equals 20 volt subtracted by the current, which is going to be 1/3 times 20 is going to be 20 divided by 3. So what do I have over here? I do have 20 divided by 3. If I just consider around 7, it's 6.666, but let's make it as 7. I do have a 13 volt. So 13 volt is going to be my what? Is going to be my open circuit voltage. Then I have to find what? I have to find the amount of resistance that I can see from point A and B. So if you just look at the circuit, let me just redraw that one. At this point, I do have point A, I do have point B, I do have one resistor which is 10 ohm, and obviously my voltage source is going to be short circuit. I do have another resistor at 20 ohm and a short circuit. If you look at it from this point of view, you see that 20 ohm and 10 ohm are going to be connected to each other out of 2 points, A and B. So at this point, 20 and 10 are not going to be series, they're going to be parallel. So I do have 20 multiplied by 10 divided by 30. If you do that one, 20 divided by 3 is going to something around 7 ohm is going to be your total resistance. It means that right now I can redraw my A and B like this. I had the RL, then I had the resistance 7 ohm, and I do have a voltage source negative 13 volt itself. As simple as that. Cool. By the way, since I do have it like this, it would be better to draw it like that, because I would like to still keep the direction of the current that comes from right to left. So at this point, either I can change this guy as negative, because I would like to keep the current like that. I can keep it as what? I can keep it as negative positive, or I can move this voltage source to another side alongside with 7 ohm. It doesn't matter, but keep it in your mind that you have to keep the direction of the current itself. So what would happen if I do have actually two sources, one voltage, another one as current? So at this point, I would like to find the open circuit voltage, and I can do it simply. So for finding the open circuit voltage, I would like to make this guy as open circuit. It means that this guy is gone. If I can find a voltage throughout this current source, I can find everything that I need. But at this point, I do have one way that is going to help me a lot. And what is that way? Just a normal KCL. What does that mean? Imagine that I do have current that gets inside of this one. This is called I1. And obviously, it's going to be divided into two current, I2 and I3. Is that so? By the way, we also can use the KCL. It doesn't matter. You can do whatever you like. So at this point, I do have my I1 equals to I2 plus I3. This part, this way, is somehow the way that we call it as node analysis. We are going to talk about it in detail, but let me just give you a very straight answer. The nodal analysis and some kind of mesh analysis or any other kind of analysis comes from two facts, the KVL and KCL. We still can use them, we still can apply them. So we don't know any name about that, but we still can use it, right? So I1 equals to I2 plus I3. Let's see. Apparently, I3 is also equals to I3 over here, because no current goes over on that part. At the same time, the current that I have over here that goes upward. So I can somehow say that I3 is going to negative 3 amp. Is that so? Is the flip up normal current. Then I do need my I1 is the amount of current that goes through this 5 ohm. If I assume that this part is V2,
the voltage of this guy is V2, and the voltage of this guy is V1, which at the same time is 25 volts, I can say that current of I1 equals 25 divided by V2 divided by what? Divided by 5 ohm. This is something that I know. Okay, I will tell you now why I'm using that. Then on another hand, I do have actually I2 is equals to what? If I assume that this part is ground, I2 is delta V subdivided by 20. What is delta V? The voltage of positive subtracted by negative. How much was that delta V? It's just V2. So it would be V2 divided by 20. At this point, if I add all of these guys together and if I put them inside this equation, the only thing that I don't know is V2. By finding V2, I can find anything that I would like. And the very first one would be about the V1 itself, because as you can see, these two guys are in parallel. So if I find V2, I do have everything that I need. So let's write it down. I1, 25 subtracted by V2 divided by 5 equals I2, which is V2 divided by 20 subtracted by 3. Is that so? At this point, I know I have to get rid of the fraction. How can I do that? I can find the LCD, or I can find just the CD, the common denominator itself. Between 5 and 20, let's assume that what is the number that is going to be divided evenly to 5 and 20? That's just 20, right? So if I multiply both sides by 20, I can get rid of all of the fractions. So if I do that, this one is going to be cancelled by this one. This is 4 times. Remember, if you would like to get rid of parentheses, you have to get rid of one at a time. 4 times 25, 4 times negative V2, going to be 100 subtracted by 4V2 equals to what? 20 is going to cancel this 20. V2, 20 is going to multiply by 30. 3 is going to be 60. So at this point, if I do the rearrangement, 5V2 what? Equals to 100. And if I move the 60 over here, 160. So your V2 would be 160 divided by 5. This guy is going to be equal to 32 actually. So we do have 32 volts. So I do have 32 volts over here, and I would consider that one as the V2 itself. So it is 32 because I do have 2 voltage sources that are helping this point, and I do have another one. So at that point, I do have the V2 as 32, and that's it. My Thevenin, or some kind of the open circuit voltage, is going to be 32 volts. What about the R Thevenin? What about how I can find the amount of resistance that I can see throughout over here? As you guys know, we have to do 2 things. The very first part is getting rid of, maybe it would be better to just use this razor to make it better for you. So at this point, I have to get rid of this guy, which is going to be my current. Right now is going to be open circuit, and I have to make this guy as short circuit. So on that time, I do have my 20 and 5 is going to be in parallel. So I do have 20 multiplied by 5 divided by 25 is going to be just 4. Then I do have another 4, and it's going to be what? In series with this 4. So 4 plus 4 is going to be 8. So my open circuit voltage was 32, and my open circuit, some kind of resistance, is going to be 8 ohm. As simple as that. So let's talk about the power of simplicity. Actually, we use that to prove something. Once the Thevenin equivalent is found, whatever number that you have, you can connect it to any kind of resistor you like and analyze its performance instantly without having any kind of issue reanalyzing the whole circuit. Imagine that we did our circuit and we found that VThevenin is 8 volt and our Thevenin is going to be 5 ohm. So I'm going to connect that code, for instance, to a 20 ohm. And right now, I would like to see that how much current is going through my load itself. So IL is going to be 8 volt, obviously, divided by these two guys are in series, divided by 20 plus 5, 0.32 amp. What about the voltage? The VL is going to be 8 subtracted by the amount of voltage drop that I have over here, or I can use the voltage divider rule. I do have 8 times L divided by the total resistance, or since I do have the 20 and I do have a resistor, I do have the current, I can multiply them together, and finally I can find the voltage. What about the amount of power that this guy is going to dissipate? We know P is equals to V times I, so it's going to be 20 times, it's going to be 6.4 times 0.32, and I do have my power. As you can see, everything just got simplified. So let's talk about the second revelation. Let's talk about the Norton Theorem. What does it say? The Norton Theorem would say that any two-terminal linear network can be replaced by an equivalent circuit consisting of a single current source and in parallel with a single resistance that we call it as Rn. So the Norton current is the short circuit current at the terminal. It means that whatever terminal that you have your RL, you have to get rid of it, and instead of just getting rid of that, you have to make it short circuit. Then you have to find the current that goes inside that specific place, and you have your I Norton. The R Norton is going to be identical completely to Thevenin and Norton. It means that how much current, how much resistance I would see out of that point A and B itself. So again, the I Norton, it means about the short circuit, it has a couple of steps. The very first one is that place a short circuit, a wire across the load terminal A and B. Instead of whatever you have over there, you have to just simply put a short circuit. Calculate the current flowing through this specific short circuit, and this current is considered as IN. So that R Thevenin is going to be the same as Rn itself. And the one good thing is that all the time you can convert one to another one. It means that your I Norton is going to be your V Thevenin divided by R Thevenin. So we can see that over here. Imagine that I do have a case that I got the V Thevenin and I got the R Thevenin. I don't want to spend my time in order to find the I Norton itself. So what I should do, I have to find the I Norton by itself by V Thevenin divided by R Thevenin. It means that I can convert to this guy, keeping the R Norton, but make sure that at this time should be in parallel. Then I can have the I Norton itself. As simple as that. So let's see an example over here that at this point I'm asking you guys to find what? To find that I Norton and R Norton or R Thevenin, doesn't matter. So at this point I have to make this guy as short circuit, right? Right now I have to find how much current that goes this way. Since I do have a voltage source and current source, I would like to use the KVL. What does that mean? It means that if I can do this, let me just think about it, rather than just using the KVL, maybe we can, I'm trying to think with you guys. So I do have a short circuit. Let's consider the fact that this node is my beloved node, and I would like to call this one as V. So at this point I would like to see that I1, obviously this is the total current, and at this point I do have another current gets in, so it doesn't hurt that if I change the direction of current one time and make it as what? And make it as I1 and this I2. So I2 equals to IT plus I1. Is that the case? So if I consider that my I1 is already there, is 4 amp, what about IT and what about I2? So I2 equals to delta V divided by R resistance, the amount of resistance that you can see. At this point, since I do have a short circuit, this guy is completely gone because the total current goes through that way. And if I do have this guy as ground, everything is going to be simple, right? So I do have my positive voltage, which is just V itself divided by, subtracted by 0, divided by 3. As simple as that. Then I do have my what? I total is going to be divided. It's going to be a division of voltage over the resistance. Since the voltage over here is just 15, let me just put it, it's 15. So what? I do have 15 subtracted by V divided by what? Divided by 3. So I do have everything that I need. It means that I can solve it for V. If I solve it for V, I can find how much current goes this way. So what I had, I2 is equals I total plus I1. What is I2? Is V divided by 3 equals to I2. I2 is how much? We found out that I2 is 15 subtracted by V divided by 3. Then equals a plus I1, which is going to be 4 amp. So obviously we have to get rid of this 3. The only thing you have to do is just multiply both sides by 3. If you do that, V equals 15 subtracted by V plus 12. As simple as that. So at this point, I can move the V over here. 2V equals to 27. So my V equals to 13.5 volts. Am I done? No, because I still have to find how much current goes through this way or goes through this branch. So I need to V divided by R is going to be my what? My I2 that I need. So 13.5 divided by 3. So if you do this, some kind of division, should be something around 4.5. So 4.5 amp is my I Norton. What about the R Norton? Again, it's simple. The only thing you have to do is just look at the whole circuit through here, make this guy as open circuit, make this guy as short circuit. What you have only 3. You have what at this point? So at this point we still have the 6. So you have 3 and 3 are going to be in series with each other, and you have both of them in parallel with 6. So if you find that one, your R Norton is going to be 3 ohm. It means that right now I can rewrite the whole circuit as one resistance, 3 ohm, in parallel with the current. We have to look at the direction of the current, which is going from bottom to top, 4.5 amp, and we can simply convert it to the thing that which is the V Thevenin that we like. Let's look at another example. At this point, I would like to find I Norton and R Norton. What I should do, I should make this guy short circuit. I don't need this guy anymore, and I have to find a current that goes that way. Again, let's look at the KCL. I1, I2, I3. I do have this guy as this one. By the way, you guys also can use the KVL. We had it over there. If you guys remember previously, we were talking about it. You can just use the KVL, doesn't matter. But most of the time, this KCL works better. It's completely based on your judgment. It doesn't matter what we use, but at the end of the day, all of your answers should be right. Or both of the answers that you found should be the same. So I1 equals I2 plus I3. I1 equals to delta V of this guy. Right, let's just assume that this one is V. This one is obviously 12, so I1 is 12 subtracted by V divided by 2. Then I do have the I2. Should be what? V subtracted by 0 divided by 6. And then I do have I3 is just what V subtracted by 0 divided by 3. Simple as that. So I have to apply everything that I need. I have over here in this some kind of circuit in this equation itself, and I can find everything that I need. 12 minus V divided by 2 equals I2 V minus 0 divided by 6 plus V divided by 3. Obviously, we have to find the LCD. The LCD would be 6. So if I multiply both sides by 6, I can find everything that I need, or I can get rid of fractions. So if I do that with this guy, it would be 3 times 12 minus V equals to 6 multiplied by this one, just getting rid of this denominator. So we have V, and 6 that's multiplied by that one, it would be plus 2V itself. Let's just do this multiplication. We do have 36 subtracted by 3V is equals to V plus 2V. So if I just rearrange that, 36 would be 6V, and our V is going to be what? 12 volts. Am I done? Obviously not, because I need to find how much current goes this way. How I can find it? I Norton equals the 12 volt, right? The 12 volt divided by 3 is going to be 4 amp. Simple as that. What about the R Norton? R Norton is going to be how much some kind of resistance I see from point A to B. At this point, I have to make this guy as short circuit. If I do that, what I do have, let me just clear this. I do have 2 ohm, which is in parallel with 6 ohm, and then they have to be in series with 3 ohm. So what would happen if you find the 2 ohm and 6 ohm? It would be 2 multiplied by 6 divided by 8 would be 12 divided by 18, which is going to be something around, consider as maybe 0.8. Then you have to add it up with 3. If you add that up, it would be right 3.8. So R Norton is 3.8, and my I Norton was how much? I Norton was 4 amp. I can redraw the whole circuit by this. The current goes that way. I do have Rn, and I do have my R. R Norton is going to be 3.8. and I Norton is going to be 4. As simple as that. So choosing the tool, this is some kind of a strategy guide for equivalence. When do you have to use, or when it would be better you guys to use the Thevenin? If the original circuit is dominated by the voltage source, that would be way better to just use the Thevenin voltage, because Thevenin is completely related to voltage. If converted are primarily in series, that would be better. If you need to analyze the load voltage, obviously you need to be better to have the Thevenin, and if your calculation for open circuit voltage are way simpler, it will be better to do that. On another hand, if you do have a circuit that's the original one is dominated by the current source, it will be better to use this the Norton. If components are primarily in parallel, that would be better to do that. You need to analyze the load current, and finally, if you make anything short circuit, you can have the you can have a better or simplified version of calculation. So the ultimate strategy, it says that use whichever method is easier to calculate for a given circuit. Feel free to find one and then use source transformation to get another one. The source transformation, as we just saw over here, we were talking about this. We can convert the one voltage source and resistor in series to another current source and resistance in parallel. So let's talk about the final challenge, achieving the maximum power transfer. What does it say? Imagine that I do have RL and I do have my equivalent, the Thevenin or Norton, doesn't matter. For a given source, what load resistant RL will absorb the maximum possible power? At this point, I would like to find my RL, the specific RL, or I can adjust it in order to find how much the RL should be, in order that I can make sure the amount of power that guy is going to have is going to be maximum. Maximum power is delivered from a source to a load when the load resistance equals to the source Thevenin resistant. RL should be equal to R Thevenin. So at this condition, RL is R Thevenin and P is going to be V to the power, and the P max is following this formula. V Thevenin to the power 2 divided by 4 R Thevenin. And the load voltage should be V Thevenin divided by 2. It's so simple in order to prove that, but just in case, you can memorize the formula itself. The very important thing, maximum power is not going to be maximum efficiency. Remember that. At P max, the efficiency is exactly 50%, as the source resistance dissipate as much as power as the load. Why? Because when we say that RL is going to be R Thevenin, and my source, whatever that, is going to give 50% to RL and 50% to R Thevenin itself. As you can see over here, your efficiency is going to be what? Be 50%. Remember that. So let's see another example. Imagine that question 1 is that what is the ideal load for the max power? Obviously, the ideal load would be RL and R Thevenin should be the same. Any number rather than that is going to reduce the amount of maximum power that your load can get. What is the question number 2? What is the maximum power delivered? So P max is going to be V Thevenin to the power 2 divided by 4 times R Thevenin. What is the V Thevenin? Is 12 volt. What is R Thevenin? Is going to be 8. 4 times 8 is 32. So V Thevenin to the power 2 divided by 4 R Thevenin is going to be 4.5 watts. So either you can use this way or you can use the normal formula we know about the Ohm's law. You can add your 8 over here. You can have 8 and 8 in series. So you can find the current, then you can find the power. It doesn't matter. So application is about impedance matching in audio amplification, radio antenna, and the solar cell arrays. So at this point, we learned something about one of 2 important ways that we can use in order to simplify our circuit: Norton and Thevenin. On that point, you can simplify all of the complicated things that you have around yourself, which are related to linear condition when you do have voltage and current source, maybe independent or dependent, and you have resistance. That would be way better to use that on that time. Choosing whichever you want, whichever you can use is completely in your pocket. You have 2 ways. You have 2 guns. You can put out whatever you like or whenever you want. By the way, I give you a couple of hints that you can use in order to make sure at what point it will be better to find, it will be better to look at which one. So I also put some kind of a question for you at the very end of this slide. It will be better to you guys to work on it, try to rewatch all of those 5 to 6 questions that we had and make sure that everything is okay. Try to pause the video, do it by yourself, and then try to look at the answer and some kind of compare it with my answer. Again, try to pause the video, move it back, and then redo it to make sure that you completely understand it. For this one, I put the answers that I thought it would be right, so you can obviously check your answers online, and maybe someone would say, no, your answer is not right. And at that time, I promise I'm going to record a video for you and completely explain this one. So again, thank you guys for being here with me. Please don't forget to like, share, and comment if you like the video. That would be so helpful for me. My name is Mahmoud Kiasari. Have yourself a great day, night, whatever. See you around.